Here we're going to be talking about even functions, odd functions, and functions that are neither. So we have those three separate types. So if we have a function that is even, we are going to be algebraically showing whether or not the function is even, but I also want to show you visually what's happening because we're going to discuss these things later on this year. So if we have a function f of x, to determine if it's going to be even, what we want to do is we want to substitute in f of negative x. And hopefully what we want to happen is the output for f of x should be exactly the same thing as the output for f of negative x. So down here, this is going to be, our even functions are always symmetric about the y-axis here, because if I have a positive x and I have a negative x, their outputs are exactly the same when we fold it over that y-axis. Now, functions will be odd if we have the function f of x and we're substituting in f of negative x. In order for us to tell whether or not it's going to be an odd function, is we want for the output to be exactly the opposite of the original function. So that's going to be symmetric about the origin right here. So that means that if you spin this around 180 degrees, it's going to look exactly the same. So this coordinate right here, xy, if I have a negative x and I want for it to be exactly the opposite output, it's going to be mirrored across that origin or about the origin all the way down. Okay, we're also going to have functions that are going to be neither. When we figure this out algebraically, it's not going to be exactly the same as the original function. It's not going to be exactly the same as the opposite of the original function. So we'll have that option as well. We also have functions down here where it has symmetry over the x-axis. Okay, so it's not even or odd. So if it's symmetric about the x-axis, all that's happening is that your output is the one that's going to be changing to be completely opposite. So let's try a few examples together. Alright, so we have the first one, f of x is 2x to the fourth plus 6x squared plus 4. So in order for us to determine if it's even, odd, or neither, we have to substitute in negative x everywhere that we see a positive x. So we're going to have negative 2 times negative x to the fourth plus 6 times negative x squared plus 4. Well, when we do that, we actually multiply this negative x and raise it to the fourth power. We're going to get 2x to the positive fourth plus 6x squared plus 4. And this function right here is exactly the same thing with what blah 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 with what we started with originally. So this function is going to be an even function. And yes, you have to show me all the algebra that you're using to solve this problem. Alright. The next one is going to be f of x equals x cubed minus 2x. So again, we're substituting in the negative x. So negative x cubed minus 2 times negative x. This will be negative x cubed plus 2x. Now there is something that we can do to make this problem really, really nice. I'll draw this in a different color. If we factor out that negative in front of the x cubed and we factor it from the entire expression, we're going to have the opposite of x cubed minus 2x. Well, that should be a 3. This x cubed minus 2x is what we started with, but now we have the exact opposite of the original output. When you have the exact opposite of the original output, that means that this function is going to be an odd function. And again, when it's an odd function, it is symmetric about the origin. Okay. Last but not least, we have the third one, f of x equals x cubed plus 1. So we're going to take f of negative x. Okay, we're plugging in negative x cubed plus 1. And this will get us, well, negative x cubed is negative x cubed plus 1. Now, even if I wanted to take out that negative in the front and try to factor it out, this inside here says x cubed minus 1. That is not what we started with over here. So because this inside does not match the exact original's output, this one is going to be neither.